Get out your notes. Let's go.
Hi. Today we're going to talk about elements, atomic number, isotopes, relative abundance, and average atomic mass. All this information can be found in Chapter 4 in your textbook, Chemistry, Matter, and Change. First thing we want to talk about is the subatomic particles of the atom. There are 3 subatomic particles that we're going to talk about for this unit. There are more, but the only ones that we're going to focus on are the electron, the proton, and the neutron. The electron is the smallest of them all. It has a relative mass of 0. Really, it's 1 over 1800, but that's such a negligible mass that we're not going to count it. The proton has a positive charge, and it has the mass of 1 atomic mass unit. The neutron has a neutral charge, 1 atomic mass unit. If we look at the model of the atom, we can see that the nucleus is where all the matter is. So in the nucleus we have our protons and our neutrons. So that gives our nucleus a positive charge. Outside the nucleus we have our electrons.
And what is the atom mostly made up of?
Protons and neutrons.
And empty space.
And empty space. That's right, Miss Lurberg. The atomic number equals the number of protons. So if we look at our periodic table, we can determine what neutrons or protons that an atom has by looking at the periodic table. So let's go ahead and look. So if we look at our periodic table, here it is, and we look at lithium, we can see lithium has the atomic number 3, so that means it has 3 protons. And as we go across the periodic table, you see that the numbers are increasing, and that's because the number of protons are increasing. That means our atom is gaining a more positive nucleus.
So it has a greater nuclear charge.
A greater nuclear charge, that is exactly right. So let's move on. Okay, so if we look at our periodic table again, we'll see that periodic table represents physical and chemical behavior of elements. So they're arranged by increasing atomic number. That's what I just showed you. So if you look at groups, those would be the columns. So let's go back and look at those columns again. So if we look at our columns, we'll see they're right here. This is a group. This would be group 2, and so on and so on and so on. Okay? So everything in group 1 would have very similar physical and chemical properties. The same as everything in group 18 would have very similar chemical properties. So if we look again, here's our periodic table, and if we look at sodium, sodium's in group 1, so it would have very similar properties to everything else in group 1. If we look at our elements, usually our elements is going to have the atomic number on the top, and it'll have atomic mass on the bottom. If your periodic table is different, there's always a key on the periodic table. You want to check it to make sure.
You should pull out your periodic table now because you're going to need it to answer these questions.
So now let's look at the questions. The first one says, state the number of protons for the atoms of the following. Okay, so we're looking at the following. We have nitrogen, sulfur, and barium. So go ahead and pause this video for a second so that you can look at your periodic table and determine how many protons each atom has. So now we're looking at it, okay, and we want to look at nitrogen. So if I look at nitrogen, I'm looking at the atomic number, that's 7, so that means that it has 7 protons. So moving on. The number of electrons. So the number of electrons determines whether the atom is going to have a charge or not. So a neutral atom, and that's all we're talking about in this chapter, will have the same number of electrons as protons. So the net charge will be 0. So if we look at it, the number of protons is going to equal the number of electrons, because we want our positives of the protons to be neutralized by the number of electrons, which is negative. Moving on to the mass number. So our mass number is equal to the protons and the neutrons together within the nucleus. Because we know in the atom, the nucleus is really the only place where our mass is. So we're looking at these atomic symbols here, And so we want to look at it, and I'm going to say so let's go back. So I'm going to look at it, and we're going to determine what the mass is, what the proton numbers are, and what our neutrons can be. So let's go ahead and pick helium. Okay, so we know that helium's atomic number is 2. So that's going to equal our number of protons. We're looking at the atomic mass right here, and the atomic mass is 4. So that means that if we take the atomic mass, which is our protons plus our neutrons, all we really have to do is subtract the protons from it. So we would say 4 minus 2 equals 2 neutrons. So that's how you determine how many neutrons your atom is going to have. It's going to be the atomic mass subtracted by the proton number, which is your atomic number. So isotopes. So isotopes pretty much is the weighted average of all the isotopes that that particular atom has. So if you look at the mass number on your periodic table, that mass number is the average of all of the atom's isotopes. So really, all the atoms on the periodic table are isotopes. They just have other brothers and sisters. So if we look at it here, it says atoms with the same number of protons. That means that I'm not going to change the atom, but it has a different number of neutrons. So if you think about it, the protons identify the atom because it's equal to the atomic number. Atoms of the same element, but that means they have the same atomic number with different mass numbers. So what we're going to do is we're going to go to this little website, play a little game. Let's look at it and see how we can make isotopes. Okay, so looking at this, we have a hydrogen atom. That's our isotope. And what we want to do is we want to make different isotopes. So we can't change the proton number, because if we do that, we change the actual element. So what we can do is make it an isotope by adding neutrons. So if you look at it here, our proton number is still the same, but our neutron number is different. And since we have this unbalanced ratio of protons to neutrons, it makes it unstable. So we can take one away and see if that helps with the stability, and it does. So it's a little more stable, and it's more abundant in nature. So let's look and see. So really, that's the abundance in nature, which isn't high, but if I was to put this other neutron here, it's so small that it's not even going to be counted because it's so unstable. So let's reset it and try another one. We'll try carbon. Carbon has 3 isotopes. So if I look right here, the mass number is 12. That means that I have 6 protons and 6 neutrons, and I'm going to go ahead and change it and add an isotope, make it an isotope. So now the isotope is going to be carbon 13, because now I have an extra neutron. Let's look at its abundance. So abundance here is 1.07%. Not very abundant. So let's look at another one. So we made it now carbon 14, and look, it's so small, it's very unstable, that we're not going to see a lot of that. It's too small. So let's go back to our PowerPoint. So now we're going to talk about isotopic notation. So doing isotopic notation, what you're going to do is you're going to have a chemical symbol, that's our X, and then you're going to have your mass number. Your mass number is your neutrons plus your protons, which is the atomic number, and then you're going to have your protons. Okay? So that's how you're going to represent your isotopes. So now what we're going to do is we're going to look at this for your turn, and we're going to actually determine the number of protons, neutrons, and electrons for each of these isotopes we have listed. So go ahead and pause me for a second and do this work on your own paper. Alright, so what we're going to do now is I'm going to go ahead and do the first ones, and then you do the other ones yourself on your own paper. So we're looking at carbon 12, so we know that the mass number there is 12 and the proton number is 6. So we know that the atomic number is the same as the proton number, so that would be a 6. Okay? So now we're looking at the neutron number. To determine neutrons, you're going to take your 12 and you're going to subtract the 6, and so that means I would have 6. And then your electrons, since this is a neutral atom, we're going to go ahead and say that the proton numbers has got to equal the same as the electrons to get our neutral atom, so that would be 6 as well. You do the other two yourself when you submit to Edmodo. All right, so your turn. An atom of zinc has the mass number of 65, okay? So we're going to look at zinc, the number of protons, so let's go back to our periodic table and look that up. So let's look at zinc. So zinc is right here. Here's our zinc. So we're looking at it, and we know that the atomic number there is 30. So if the atomic number is 30, then that means that this is the right answer. So it has to be 30. Okay? So now it says the number of neutrons in zinc. So what you would have to do is look at your mass number and you subtract 30, and that would give you the number of neutrons. Okay? So if I subtract 30, that means that my neutrons would be 35. Okay? What is the mass number of a zinc isotope with 37 neutrons? So to do that, you would have to take the atomic number, which is 30, because we know that the nucleus has protons and neutrons, and you're going to add your neutrons, which is 37, so that means your correct answer would be 67. So now your turn. So we're going to write the atomic symbols or isotopic symbols for the atoms with the following. So now what you want to do is look at your periodic table, go ahead and pause for a minute so that you can answer these questions. And I'm going to pull up my periodic table. Okay, so I'm looking at it and I saw that the number of protons was 8. So that means that it's got to be oxygen, because remember that proton number identifies the element. And then it said that it had 8 neutrons and 8 protons. So that means that the atomic mass has to be 16. So now if I'm going to write my isotopic symbol, I'm going to put 8 on the bottom, because that's our atomic number. I'm going to put oxygen, and then on the top I'm going to put my mass number. So I know these two together is going to equal my mass number, so that would be 16. So now it says an atom has 14 protons and 20 neutrons. So we know together that would equal our mass number. But the first question says, what is the atomic number? We know that the proton number is going to be the same as our atomic number. So that means that answer would be 14. Okay? It says its mass number is what? We know that protons and neutrons together equal our atomic mass. So 14 plus 20 is 34. So that would be our mass number. And if we look on the periodic table, we know that number 14 on the periodic table is silicon. So we know it's got to be silicon based on our proton number. Okay? Another isotope of this element, let's think about our isotopes. We know that the proton number identifies the element. And all of these elements have got to be silicon, because silicon is 14. So we're looking at it, it could be this one, and this could also be an isotope of this element. So this would not be right because it doesn't have the same atomic number. All right, so masses of our atoms. So how we determine masses of our atoms is really based on carbon. So a scale was designed for atoms and given their small atomic masses in atomic mass units. An atom of carbon-12 was assigned an exact mass of 12 AMUs. And this is why we're using grams. We can base it off of the scale that they used. So relative masses of all other atoms was determined by comparing each mass to carbon-12. So if we look on the periodic table, we know carbon-12 is what everything's judged by. So an atom twice as heavy would have the mass of 24. And if we look on the periodic table, magnesium would be that particular element. Okay? An atom half as heavy would be 6 AMUs. And there's not really an element on the periodic table that has the mass of 6. But this is how we're judging all the other atoms. It's just really based off of carbon. So atomic mass on the periodic table, if you look at that mass on the bottom, that's pretty much an average weight of all of the isotopes that exist for that particular atom. So it gives the average atom of each element compared to carbon-12. Average atom based on all isotopes and their abundance. So if you think back to the atoms that we made before, we saw that carbon-12 and carbon-14, they probably wouldn't really use carbon-14 in that mix because carbon-14 is almost non-existent. So really they're going to base it off of atoms or isotopes that exist.
Ms. Bodell, if you're in the building, could you call Ms. Siders? Thank you.
So the atomic mass is not a whole number because we're taking the average. That's why we have those decimal points. Okay, relative abundance. So relative abundance, you probably learned this in biology. Pretty much all it is a ratio. So we're going to look at the relative abundance of these kitty cats. So we're looking at the kitty cats and we're saying, okay, given the sample of 6 cats, what is the relative abundance of the striped cats or the black cats? So we're looking and we see that we have 6 cats. And we're going to count them, 1, 2, 3. So I'm looking and I'm saying I have 3 striped cats. So that relative abundance would be 3 over 6. That would be the relative abundance of our cats. So now we're looking at a bunch of cats. And we want to say, what is the relative abundance of cats with diving masks? So I'm looking at my cats with diving masks, and they're pretty cute. So I'm going to look at this one. This one is 1. He's looking a little cute. And then this one. They look like they're ready to go for a swim. So we have 20 cats total. So that means my relative abundance would be 2 over 20. Okay? So the relative abundance of white cats would be the same, 2 over 20. And then the relative abundance of gray cats. Let's look at them. We have a gray cat, 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 a gray cat. So how many gray cats is that? Let's count. 1, 2, 3, 4, 5, 6, 7, 8. So that would be pretty much 8 over 20. So if we look at here, here's our solution. Okay? I know I said 6, but dang, after looking at it, it would be 8. So now let's talk about our percentage, okay? So when we do isotopes, we're going to be counting them, our sample, within our sample, and then we're going to determine the relative abundance by giving a sample size, okay? Now to figure out the percent abundance, all you would have to do to this is just multiply that by 100, and you would get your percent abundance. All right, so your turn. So what we're going to do is we're going to start off by actually looking at the atomic mass of each element. And we're going to look to the hundredths place, because that just makes everything more specific and more significant. So I'm going to go ahead and look at my periodic table again. You get yours out and look at it. I'm going to go and look at it and see if my masses are right here. So all I'm going to do is copy down the mass and use my decimal places. Okay, so you do that on your paper and turn that into us. Okay, so calcium would be 20. What is that?
40.02.
Let's look at it again. Okay, so calcium would be 40.08.
Yeah.
Okay, so if I put on my paper here, I would put 40.08. Okay, all right. So let's move on. So calculating atomic mass. So what we're going to do is, first of all, if we have a sample size, we're going to get the relative abundance of our isotope by counting all of the isotopes and then putting the particular one we want on the top. Okay? Then we're going to get our percent abundance, and that's by multiplying that value by 100. Then we're going to get the mass of each isotope, calculate it by mass of the isotope times our percent abundance, and then we're going to do the same thing for the next isotope, mass of the isotope 2 by our percent abundance, and so on for ever how many isotopes you have. And we're going to divide that by 100 to get rid of the percent, add them all up, and that would give us our weighted average. An example would be, what we would do is we would take our masses of magnesium. So if I'm looking at it, magnesium 24, I would take that, here's my 24 as my mass. I would multiply it by my percent abundance, and I would do that for each one, and then I would add them all up, and that amount would be 24.3. And that's the same thing that's on the periodic table.
Well, and if you look at this, which one's most abundant?
I would say the one that's most abundant is the one with 78.7%.
Right. And so you can almost look at, okay, yes, we have to be able to solve it, but if you look at it's 78% abundant, when you get your answer, you want to check and make sure that the one that's most abundant is mass is closest to your answer. So 24 is the mass that is 78% abundant, so you would expect your final answer to be close to the one that's most abundant.
That is exactly right.
So use your intelligence when you solve this.
Right. You want to use some logic. Look at those answers and say which one's the closest. My answer doesn't look right, so maybe I should do some recalculation. All right, so your turn. So this one's a little bit different. This one is, you're not given, wait a minute, you are given the percentages. Okay, so this one it says you have a gallium metallic element found in small lasers used in a compact disc player. In a gallium, there is 60, there's our number, 60.2% of gallium 69. Okay, and then you have the next one is 39.8% of gallium 70. Okay, so what is the atomic mass of gallium? All right, so what you're going to do here is you're going to set it up to where you have your gallium. So I have my gallium here, I have my percentage here, and I'm going to divide it by 100. Okay, we want to get rid of the percentage. And if I do that, that's going to equal 41.5. So then I'm going to look at the next one, and I'm going to take my 70.9, and I'm going to multiply it by my 39.8%. We're dividing it by 100, and then I should get 28.2. Okay, so then I'm going to add them up, and I get 69.7. So if I look at it on the periodic table, I should have a number very, very close to that.
Yep, 69.723.
Let's just check it out and see. So gallium, let's see, where is gallium? Right here, and look, 69.72. That is so close.
Yeah.
Okay. All right. So what if you have two percentages and you don't know either one? What are we going to do?
That makes it a little harder. But we do know our masses.
Yep, we do. We have
And we
our
know what the
masses.
average atomic mass is.
We just got to figure out the percentages. So what we would have to do is we would have to assign X and Y values.
Oh, now we're getting into math class.
Not even good.
Ugh.
All right. So what we're going
We
to
love
do,
math.
yes, we do love math. So what we're going to do is we're going to look at X and we're going to look at Y, right? And we want to know the percentage of each one. So we're going to determine Y in terms of X. The same thing y'all do in math.
You should make sure you understand this. You will see it in your future. So
Yes.
let's really pay attention.
Let's pay attention and focus. So now we're going to look at it and say, we know that X and Y is going to equal 100%. We know that for sure, okay? Because we only have two isotopes, and we know they got to equal 100%. So what we're going to say is we're going to manipulate our equation here, and we're going to solve in terms of Y. So Y is going to equal 100 minus X. If we know X and we subtract 100, we would get the percentage of Y. So now we have to solve for X. Okay. So we know, we look back at our formula again for average atomic mass, and why the hundreds under there is because we know we got to get rid of the percentage. So now we're going to look at it. We know that X times 10, right? That's our mass. We don't know the percentage, right? That's our formula for the first isotope. The second one is going to be our Y. So we know that Y equals 100 minus X. So we can put that in our percentage for Y.
Now we only have one variable.
Right. And so now we're going to look at this and say we're going to multiply that by our other isotope, which is 11. And we're going to put that over 100 because we want to get rid of our percentage. And we know the average atomic mass is right here because we were told that. So now all we have to do is we're going to multiply through by 100 to get rid of our 100. So that means this has got to be multiplied by 100, this by 100, and this has got to be multiplied by 100. So we'll do that, and this is what we get. Okay? So we're getting rid of the 100, right? Getting rid of the 100, so it's gone. Okay? Does everybody see that? That's canceled. That's canceled. That did not cancel. Okay? So now what we're going to do is we're going to collect our x variables, combine them. So when we combine them, we take 10 minus 11, so we get a negative 1x. And we're going to combine these and we get a negative 20. So now all we have to do is divide by our negative 1 and we get 20%. So now we know that x is 20%, so now we just plug that in and subtract by 100, so we know that B11 is 80%. So now you try this one yourself. So you do this one yourself, and then we'll check your answers on Edmodo. Thank you. Glad you were watching.